right, my darlings, we are going to talk about different pairs of lines and angles. So right now, we're just naming them. What do they mean? So just kind of like definitions here. So parallel, you've already seen parallel lines in a plane, but now we're talking about parallel lines in space, but they're the same thing. They're two lines, they're going the same direction, they never intersect, and they're always parallel, even if we don't draw they're always coplanar. Even if we don't draw the plane, they're still coplanar. So a basic example would be line AC and line DB. These would be parallel to each other. But just to show you that even if the plane is not drawn, they're still parallel, line AC is also parallel to line GJ. Okay, so parallel lines, they have to be going the same direction and they never cross, and they are coplanar. All right, so intersecting just means they have a point in common. So my example I gave was line CD and line DJ. So they have to have a point in common. So intersecting lines are always coplanar. Okay. Coincident. This actually just means they're the same line. This is what happens when we're graphing and we get infinite solutions, because when you graph them, they end up being the same line. So line CE is right here, and line EH is right here. So if you extend and put arrows, they're actually the same line. So those two lines are called coincident. And they are also coplanar. But being in space, we have this extra type of line. It's a pair of lines that are called skew. So skew means that they don't intersect, but they're not parallel. So they're not going the same direction. They're going two different directions. So like here, line CD is going left and right, and then line JG is going backwards and forwards, and they don't touch, they don't intersect, because CD is up here at the top and JG is down here at the bottom. So those are called skew. All right, and mainly we're focusing on angles in this chapter. So we're also going to talk about pairs of angles, and this happens when we have two lines cut by a transversal. A transversal is just a third line that crosses the other two lines. So that's all it is. And notice we get 8 angles formed. Depending on where the angles are, they have different relationships to each other. So the first type is called corresponding. It means they're in the exact same position in these 4 and in these 4. So like upper left. So 1 and 5 are corresponding. Upper right. 2 and 6 are corresponding. Lower right. 3 and 7 are corresponding. Lower left. 4 and 8 are corresponding. Then we have what are called alternate interior angles, which we always shorten to AIA. Like I said, math people don't like to write out all the words, so we say alternate interior angles, or we say AIA. So alternate means they're on opposite sides of the transversal. Interior means that they're in between the two lines. So they have to be on opposite sides of the transversal, but in between the two lines. So 2 and 8 are alternate interior angles. 3 and 5 are alternate interior angles. Then we have alternate exterior angles. So AEA for short. And again, they're on alternate sides of the transversal, but this time they are exterior to the two lines. So they have to be on the outside of the two lines. So angle 1 and angle 7 are AEA. Angle 4 and angle 6 are AEA. And then we have one last type called consecutive interior angles, or shortened to CIA. Or some people and some books call them same side interior angles, or SSI. So in the shortened form, I like CIA just because, you know, it's the CIA. But for actual telling you where it is, I think same side interior is more descriptive. So they're on the same side of the transversal, interior to the two lines. So they're either both on this side or both on this side, but they have to be in between the two lines. So 2 and 5 are CIA, 3 and 8 are CIA. And we are done with the types of pairs of lines and pairs of angles.